Hello, welcome back, and now we're gonna go over milestone 2, procedural walking. So, jumping into milestone 2, now we're gonna talk about procedural walking. And because I crunched it in, a lot of the stuff from procedural walking into the first milestone, my first progress is already an unpolished version of a walking animation. So, when I started working this one, let me show you what I have right now. So this is the dude, he walks, you see, someone walks, so it's buggy, but that was my first version of it, my first iteration of the walking. Um, let's jump to the boring part. Scripting. So what did I do differently now? Now I have this guy here, Lerp. So what does Lerp do? So what did the difference differently? Okay, so now I changed a little bit of this guy here. This guy here is a little bit different. Now what I do is I check this is between the next position and the hit point. So why I do this? Because this one it allows me to check better the distance between because when the player stops walking, when the player stops stepping, next position, and current position become basically the same thing. So I can check the next position and the hit point of the raycast, which the raycast always points a little bit forward, forward from the player. Here, as you can see, right of spacing plus vector up, so it's always a little bit forward. But so I check with this one, the ground layer. So that's why I'm using next position and hit point instead. As previously I was using current position and next position. So now next, Lerp. We have this little guy now, Lerp. So what is Lerp doing here? So what's going on is, since it's animation, I need the player target, the animation target, which is this little guy here, this little red square here. So in precision animation, most of the constraints have a target, in which if you can look here in target, here, in the target, it's where the feet will be. In this case, I can't really move it because my animation is already setting it. But let's say on this guy here, for the left arm, if I pull forward, okay, this one also works. But by pushing it, if I push it, wherever I push the target to is where the limb will follow. And because I need to move over time to simulate an animation, I need lerp. So I'm gonna be lerping the position using a sine wave. So this is how a sine wave looks. As you can see, it goes up and down, it's a wave. So when talking about precision animations, especially for walking, most of programmers choose to use a sine wave. As you can see, because then the player's feet is going to be go up, and then touch the floor again. Up, and touch the floor again for the side animation. And what the lerp is doing is just there to lerp. Yeah, to lerp the foot position based on the sine wave. So as you can see here, the Y is the Y here is going through a sine wave using the lerp, which the lerp checks the current position of the feet. So it's going to be lerping between the old position and the next position, which the old position is where the feet is currently placed, and next position is where the raycast is and defined as a good position. So through here, as you can see, next position, hit that point, and after all this, so the lerp starts increasing over time here. As long as lerp is smaller than 1, because if it's 1, you finish it, the lerp is done, right? So as long as the lerp is smaller than 1, the animation plays. So when it goes above 1, falls into the else, sets the old position, and then it runs the script all over again. So that's the first one for my procedural animation. Now we're going over to my second iteration of the procedural walking animation. Let me show you around the new changes. It looks much more natural. Both feet move differently. Anyways, it's not perfect. It's my second iteration, but this is how it looks. So you can see, both feet walk in different, don't walk at the same time. So let's go over the code for it. So first, let's start with some of the changes. First change. Now I check for other feet using other is moving. So what is other? Other is just another game object that has the same script, which would be the other feet. So if the other feet is moving, I call the function, yeah, here, moving. If the other one is moving, which means the lerp is smaller than 1, then you can't move. this feet can't move because the other feet is already moving. So, and also make it a bit more fail-safe by making so that I check also the lerp. Here and now reset the lerp back to 0. Now I'm using the rigid body's velocity to calculate how far the feet is going to reposition itself. So the higher the velocity, the further the feet will reposition. So smaller steps, smaller distance. The feet is going to move not so much. When the moving faster, the feet is going to walk more bigger distance. But I will have this velocity prediction modifier. What does this do? It's just a number here, as you can see, 0.3, which it just reduces the number so that it makes it more manageable. So now I'm going to show you, if I have a higher number, the feet is going to like lunge more forwards because of speed. So let's use 1. So as you can see, the feet is more erratic. The feet will like, it will recalculate sometimes midway, mid swing, because it's going to be too fast, going to be too forward. And when I spin, the feet is going to go extremely erratic because of the modifier. So that's why we keep it around 0.3. Going back to script, what else changed? I now calculate the rigid body velocity here, just to make sure that I'm using velocity, because my rigid body's speed was a bit funky and it was not calculating correctly because the way that I had set up previously my character controller. So I had to use the velocity, and that is my second iteration of the player walking. Hello again. So now we're gonna go over to the next part of the procedural walking animation, hip animation. So what goes on? So as you can see here in this image from School of Motion, when you're walking, you actually will be higher and lower depending on how your knees bend. And one thing is that with 3 models, usually the root of the character of the model is in the hips. So with this, we can make now hip movement. So how can I do it? As the player's knees is already a bit bent, when I walk, what I do is I don't know if you can see it, but he goes up and down as he walks. How do I do it? Same thing as the yes. Same thing as the dodging. What I do is I have, on my case, I just actually no same thing is I use the sine wave instead of using animation curve. I use the sine wave, which is the same one as this guy here, to lift up the feet from the ground. Here, lovely. See? So I lift up the hip animation using the hip constraint using the sine wave, which it passes by the value. So if I go to environmental rig, spine, you're gonna see that the value is gonna keep up, down, as you can see there. So the player goes up and down using the override transform constraint. You could have done this as well using an animation curve, like I did for the dodging. So dodge is disabled right now, but you could have done that way as well. About the final thing that I did for milestone 3, which is feet readjustment. So what's going on? Previously, I would have a bug in which the feet would clip to each other, which it's not very nice, right? So what I did is, as you can see now, when I rotate, the feet readjust. It's not perfect, it's unpolished. I didn't have time to polish it, but as you can see, the feet never really clipped anymore because they always readjust based on the rotation. So now let's jump into the script. So what's going on? So I have this new method, position adjustment, rotation adjustment, which takes angle to change an object, which object is just what is being rotated. So in this case, the player. So let's see. Beforehand, I've had used the player's velocity, but that didn't work out too well, because what happens is, so when the player was taking sharp turns, with the way that I had set up my player rigid body, rigid controller would take sharp turns like, let me move out. When taking sharp turns like this, the player would technically go for like a very small velocity when taking turns like this, for a very small period of second, which would cause the feet to recalculate, and it would look a bit weird. So now I'm doing so that if the player is not holding any of the movement keys, WASD, WSAD in this case, then it recalculates. This way, because if when I'm walking and do sharp turns, I'm still holding one of the walking keys. So now this one works better. So first I trigger if the player needs to hasn't got a new rotation, then get a new one. So I set a new old angle. So I get the current angle of the game object using Euler's, and then I set the final angle. Previously, I was doing final angle. Final angle equals current angle minus old angle without using the math ABS function, and that didn't work. Why? Because because on a sphere in Unity, when you go past 360, it resets back to 0, and because I was not using absolute, that it would be stuck in like 350, 355, 360, and then it would never rotate again. By using absolute, I can get negative numbers and still be able to go over the angles, allowing me to check if the final angle is bigger than the angle to increase. I set the old angle as new angle and I recalculate. So I set this thing as true, this boo as true to recalculate, which just triggers again the recalculating fit position function, and then I get the result that I showed you guys. But there's one bug that I was not able to fix because of my lack of time. So let me go really close to him, and if I start rotating really fast, his feet start going really up, really high. There's something for me to fix, but I didn't have time to fix it. And this is my final product for my milestone 2 animation. So now you can see it's a bit more fluid. If I stop and recalculate and rotate, it recalculates the feet. And when I walk, the players slightly go up and down, up and down, up and down, like in real life. And so this is it. And now I will get back to you in milestone 3.